Hello everyone, this side Mayank Jhunjhunwala from IIT Kanpur. So today we will be solving some questions on coordination compounds from chemistry with respect to JEE Mains and NEET. So let's get started. So let's start with the very first question. The type of isomerism shown by this complex COCl2 En twice is what? So basically compound is COCl2 diene twice. Okay, so let's see. So basically, how this is made, uh, when I take this compound CuNH3 6Cl3 and pass it with AgNO3, this is silver nitrate. Silver, 1 second. Silver nitrate. Then this gives me this compound. One Cl2 is replaced by AgCl and one Cl comes inside. Then I get 2 moles of AgCl because Ag and this Cl forms a precipitate of AgCl. Okay. So basically this these are formed. So my answer would be B because basically coordination isomerism is shown like this. I get these three compounds, this, and this, when CONH3 6 Cl3. Basically, it shows three forms. One is CONH3 6 Cl3, which is shown as given here. Second, it exists in this form, CONH3 5. This one Cl goes inside. You will be left with Cl2. And for this one, it is like this, CONH3 4. Two Cl comes inside and one Cl remains outside. So this isomerism in which the same chemical compound with different forms exist, it is known as coordination isomerism. So this is coordination isomerism. Okay, because different coordinates are being formed in this. You have CONH36, in this you have one Cl inside, and this you have two Cl inside. However, the overall compound formula is same because we have three Cl only. Here also three, here also three, and here also three. Okay, so let's move ahead. Which one of the following compounds is not expected to exhibit isomerism? So among these compounds which cannot exhibit isomerism, we have been asked this thing. So basically we have to check for all four compounds one by one. Okay. So let's talk about this compound. This is of the form Ma2B2. Okay. So here M is nickel and nickel is 2 plus state. Why so? Because NH3's state is 0, so it would be X plus 0 minus 2 because Cl is minus 1 equals 0, so X is equal to plus 2. So that's why nickel is in plus 2 state and Na plus 2 is sp3 hybridized. We studied this thing in chemistry. So Na2 plus sp3 hybridized. Of course, sp3 is tetrahedral in shape. Hence, the four ligands are not different to exhibit optical isomerism. So correct choice is D because there would be tetrahedral shape only because of sp3 hybridization. Okay, so this thing is first thing, and talking about this type of compound MABCD where all the four ligands are different. It does not have a plane of symmetry. Of course, it will not have because all the four ligands are different. It might be something like this, MABCD. So you will not get plane of symmetry from anywhere because these two are not same. Similarly, if you cut from here also, these two are not same. So you can't get a plane of symmetry in this type of compound. Thus, it will show optical isomerism. So these type of compounds show optical isomerism because we know that optical isomerism exhibits only when there is no plane of symmetry. And in these type of compounds, you can't have plane of symmetry. So MABCD type of compounds always exhibit optical isomerism. always exhibits optical isomerism. Cool. And in MA A2B2, as shown here, I can easily get the plane of symmetry. Thus it will show optical. I has a plane of symmetry. Thus it will show optical isomerism also. This is um. Okay, so we are talking about optical isomerism, not geometrical isomerism. Okay, once again. Okay. So basically, it is saying MABCD does not have a plane of symmetry, thus it will show optical isomerism. Whereas MA2B2 has a plane of symmetry. Why so? Because we will do it like this, and it will always have a plane of symmetry whenever you cut it, because there is a plane in which they are having mirror images. So there will be always plane of symmetry in A2B2 type of compound. So it has a plane of symmetry. Then also it shows optical isomerism. Why so? Because plane of symmetry defines GI, not OI. Okay. So it will show optical isomerism. It will not show geometrical isomerism. Tetrahedral complexes are symmetrical in all directions. So tetrahedral complexes cannot show GI. Okay, because of plane of symmetry. And MABCD shows both. They also show GI and they also show OI, optical isomerism. Cool. So always exhibits optical isomerism as shown here. And MA2B2 has a plane of symmetry, thus it will show optical isomerism also. They are symmetrical in all directions. It cannot show geometrical isomerism. So correct choice is D. Which of the following does not exhibit isomerism? MA2B2 type of compound. Okay. Moving ahead. Let me clear the screen so that you can read. Let me summarize it once again. So MABCD type of compounds shows both OI and GI. MA2B2 type of compound, if they are tetrahedral, they will not show isomerism. Okay. So NH32Cl2 is sp3 tetrahedral, so it will not show isomerism. So D is my right option. Okay. So please remember this thing that sp3 hybridized tetrahedral compounds cannot show isomerism. Cool. And instead of if this Me2B2 type of compound, if it is square planar, if it is square planar, then it will show isomerism. Okay. So if case of tetrahedral, we can say that in case of tetrahedral compounds, there is no isomerism, but in case of square planar compounds, there is isomerism. Okay. So here also geometrical isomerism. Cool. So MABC does not have a plane of symmetry, it will show optical isomerism, whereas Me2B2 has a plane of symmetry. This is for square planar. It will show optical isomerism. Tetrahedral complex is symmetrical in all direction. It cannot show geometrical isomerism. Okay. So this is one thing. Moving ahead. Question number 3. Which of the following does not show optical isomerism? Again, same question. See, let me tell you one thing. The geometrical isomerism depends upon the arrangement, like how we are getting plane of symmetry. So it depends upon plane of symmetry. Okay. So Here we are being asked about optical isomerism. So let's see. So taking a first compound Me3B3 because it is a form of Me3B3. So let's see the oxidation state. Let it be X. Ammonia would be 0 and Cl3 would be -3 equal to 0. So from here I will get X equal to +3. So here cobalt is in +3 state. So it would be like this only. 6 compounds, so it will be arranged like this. So it can be like this, it can be like this. So basically, this isomer is called facial isomer, and this is called meridional isomer, like this. And this is facial. Okay. So when it is facial, when all the three are on the same side, it is called facial. And when it is like this, one is on the different side, and then it is called meridional. Okay, so basically these are two kinds of isomers shown by Me3B3. So this is for A part. Okay, so we were asked which of the following compounds did not show optical isomerism. So A will show. En means ethylene diamine. En means, sorry, ethylene diamine. Okay, so this was the for the third question. Please remember this thing that this type of isomerism where all the three are on the same side is called phase, and when there is one in between these three, it is called meridional. Okay, so octahedral coordination compounds of type Me3B3 exhibits phase monoisomerism. This is important. Please remember this thing. Okay, so moving on to question number 4. Which one of the following octahedral complexes will not show geometrical isomerism? A and B are monodentate ligands. Monodentate means they are basically forming coordination with single compound, with single ligand. So I'm being asked that which of the following does not show geometrical isomerism. So let's see. Me3B3 has two geometrical isomerism as we have seen in the previous phase and mer. Me2B4 has two geometrical isomers. So let me draw. It would be something like this. One, you can draw it like this. Me2B4, where these four are in the same plane. And second would be M, A in the same plane and A like this, and just like this. Okay, so this is one isomer, this is another isomer. So Ma2B4 also has two geometrical isomers. So now Ma4B2 also is the same. Just replace A with B, you will get the same thing. So basically, these three have geometrical isomerism. Okay, so Ma2B4 shows, Ma3B3 also shows, Ma4B2 also shows. So this is my answer. Okay, so this was for question number 4. Again, an easy one. Let me draw it again. Ma2 for Ma2B4, just like this. M A Ma2B4 is this, and Ma3B3 I have shown here. Sorry, let me draw other one also. Okay, so these are for Ma2B4 geometrical isomers. And for Me3B3, I've drawn in previous page like this. So this is called facial isomer, this is called meridional isomer. Remember, these both are geometrical isomers, not optical, because these are dependent upon the spatial arrangement. So geometrical isomers. Okay. So, okay, again, it was an easy one. Moving ahead with question number 5. According to IUPAC nomenclature, sodium nitroprusside is what? Sodium nitroprusside is named as what? So sodium nitroprusside formula is this: Na2FeCN5NO. This NO is called as nitrosyl. This is cyano. You all know this is iron, this is sodium. Okay. So IUPAC name of sodium nitroprusside is sodium pentacyano-nitrosyl ferrate 3. Why so? Because first let's calculate its oxidation state. So let it be X. Cyanide would be -1, so -5. And it would be, NO would be +2, so it would become 0. -2, sorry. NO would be 0, sorry. Nitrosyl is 0. So it would become X equals -2 plus 5, that is +3. So oxidation state of Fe is +3. Okay, that's why we are taking 3 here. So sodium pentacyano because we have 5, nitrosyl ferrate because NO is a neutral ligand. So oxygen state +3 as I calculated here also. So because cyanide exists in -1 state, nitrosyl NO is neutral, which means 0. Okay, so from there I calculated oxidation state of iron, which comes out to be +3. So the overall name of this compound is sodium pentacyano nitrosyl ferrate. Okay, so A is my right answer. Sodium pentacyano nitrosyl ferrate. Here it is 2, it is wrong, and these are also wrong. So A is the correct answer to this question. So moving ahead with question number 6. The hypothetical complex chloro-diaqua triamine cobalt chloride can be represented as what? Okay. So it is chlor chlorido diaqua triamine cobalt chloride. Okay. So first write it clearly. So it is chlorido diaqua. Diaqua means we have two H2O molecules. So this is wrong. This is also wrong. We have left with this one and this one. Triamine, here it is triamine, here it is diamine, so it is also wrong. So this A option is the correct option. You can just see with these terminologies only. So diaqua means we have two H2O molecules. Here it is 3, so it is wrong. Here also it is 2, it is wrong. So here it is 2, sorry, it can be correct option, but it is also saying triamine, and here I don't have amine, so that's why NH3 thrice. So A is my right option to this question, which is COCl NH3 thrice H2OCl2. NH2 is not amine, it is NH3. A very simple question, just see the nomenclature and you will get your final answer. Moving on to question number 7. Which of the following will give maximum number of isomers? So again, one question on isomerism. Let's see. Okay, so it is slightly not good. No worries. Basically, it is saying that it will show linkage and geometrical isomerism. So let me check once. So it would be option number C, CrSCN2 NH34 plus. And why so? Because it shows linkage isomerism plus geometrical isomerism also plus optical isomerism also. So it shows the maximum number of isomerisms. So this is my right option. Why linkage? Because it has SCN. So SCN can coordinate in two ways. One is like SCN only, and other is from nitrogen side, so NCS. So it has linkage isomers. Why why geometrical? That I already showed you. It is M82B4 type of compound, and it has two geometrical isomers. We talked it about earlier also, like this M A2B4, or it can be like this Ma2B4. Okay, so these are two geometrical isomers, and this is linkage isomerism. Optical isomerism, it is simple, it can be D or L. Okay, so it shows maximum number of isomers, so C is my right option. Cool. So let's get going. Which of the following will exhibit maximum ionic conductivity? So maximum ionic conductivity will be exhibited by the compound which will give maximum ions in electrolytic solution. Quite simple. So the complex ion which gives maximum number of ions exhibit maximum ionic conductivity, as I told you. So it would be K4FeCN6. Why so? Because when it will dissociate, it will give FeCN6 4 minus and 4K plus, because there are 4 potassium ions, so 5 ions. This will give you 3 from here and 1 from here. So 4 ions. Here 2 from here and 1 from here. So 3 ions. And here it will give no ion because it is uh, this type of compound, Ni, coplanar compound, CO4. And it does not have any ionic, it is not an ionic compound, so it will not give you ions because it is a single coordination, like a single coordination block. So again, showing it here clearly, it will give FeCN6 and 4K plus, of course, A minus. It will give 3Cl minus and CONH36 3 plus. So 4 ions, here 5 ions, and here it would be 2Cl minus and 1 CuNH34 2 plus. So 3 ions. So maximum number of ions are for A case, so A is my right option. This will not dissociate, so it has 0 ions. So maximum ionic conductivity would be exhibited by maximum ions, and maximum ions are in the case of K4FeCN6. So this is my right option to this question. Okay, let's move ahead. Question number 9. Oxidation state of Ni in this compound is how much? Okay, a pretty simple question. So it would be, let it be X. C2O4 is in -2 state, so it would be minus 2 into 3 is equal to, this is I guess plus 4. No, it is -4. So it would be -4. So I will get X equals, this 6 will go that side, 6 minus 4, so 2. So Ni is in +2 state. Okay, which is option number C. So C is my right option to this question. Again, a simple one, just you need to know that this is an oxalate ion. So oxalate ion exists in -2 state. If you know this, then you can easily solve this question, and this is 4 minus. Okay, again, a simple thing, simple question. Okay, so let's move ahead. Question number 10. In which of the following compounds iron exhibits zero oxidation state? Okay, so this is quite simple. This is option number D only, because CO is again a neutral compound. So since CO is neutral compound, so it would be X plus 0 equal to 0. So X would be 0. Pretty simple one. So this thing is FeCO5. Sorry for this type of font. Here it is in zero oxygen state because CO is a neutral ligand. Okay, so CO is a neutral ligand, so Fe would exist in zero state here. Cool. Moving ahead, question number 11. Total number of possible isomers for the coordination compound. This is what. So basically, these are since there are two type of blocks, so it is known as coordination compounds. So what they are saying total number of possible isomers for this compound. Okay. So let's try it one by one. So basically, what we will do, we will exchange these ligands for the isomerism. So in first case, I took one NH3 that side and one Cl3 this side. So I will get one Cl and one NH3 will go that side. In the second case, what I'll do, I will. Okay, second case is basically same. So in this case, I will basically the original one is this one. This is two. Then this is three. When I will take all the NH3 with Cu and all the NH3 with PT and all the Cl with Cu. That is case number third. And now we have two to both sides. This is case number four. So basically, there are four type of combinations. So there would be total four isomers. Okay. So let me draw it here for clarity. One is being shown here, CuNH3 4, PtCl4. This is first. Second would be CuNH3 thrice, 1Cl, and PtCl3NH3. This is my second. Then third would be 2 both sides. So CuNH3 twice, Cl2, PtNH3 twice, Cl2. This is third one. And fourth one would be CuNH3, Cl3, PT, Cl, NH3 thrice. Okay, so this is my fourth one. So right option is option number D. Again, a simple one. Cool. Okay, so we are missing one, I guess. Oh, okay, so we are missing this one, Cu, NH3, not NH3, CuCl, CuCl, 4, PT, NH3, 4. Okay, but it is giving me 5, but actually this one does not exist. Why so? Because in this one, for this one, what is the problem? Here I can see that NH3 is 0, copper is 0. Copper would be X, NH3 is 0, Cl2 is -2. So it would be +2. And similarly here also, this is -2, this should become +2. So both are neutral here. And there can't be a combination of two neutral coordination compounds. So this is not possible. So one is this, second is this, third is this, and fourth is this. So answer would be 4 only, but this can't exist because both are neutral. So this is the fourth one. Okay. You can read here also. This compound NH3Cl2, NH3 twice Cl2 does not exist as both parts are neutral. For writing all combination of structural isomers, we need to keep the value of primary valency and secondary valency of all the isomers. But in this case, it is becoming neutral, so I can't do that. So these are my four isomers: first, second, third, fourth. Okay. So let's move ahead. Question number 12. IUPAC name of this compound. Okay, so it would be triamine, as you can see. Triamine, of course, it is in alphabetical order. We have to follow alphabetical order in naming of coordination compounds. So triamine bromo, it is wrong. Chloro will come after. So triamine bromo, then chloro, then nitroplatinum. So C is my right option because first B, then C, then N. So C is the right option to this question. Cool. Because amine comes first, A comes first, then B comes, so bromo, then C comes because of chloro, then N, then platinum 4, chloride, and why 4? Because let's calculate the oxygen state. It would be X, 0 for amine, -1 for bromo, -1 for nitro, and chloro -1. It would be equal to +1. So from here I would get X equals 1 plus 3, which is plus 4. So platinum is in plus 4 state. So C is my right option. Just follow alphabetical order and you will get your final answer. Not a tough one, again a simple one. Just follow alphabetical order and you will get your final answer. Cool. Now moving on to question number 13. A coordination complex compound of cobalt has the molecular formula containing 5 ammonia molecules. Okay, so there are 5 ammonia molecules. So, okay. One nitro group. In everyone it is there. So this is wrong because there are 2 nitro groups. So it is not an option answer. 2 chlorine atoms for 1 cobalt atom. 2 chlorine. Here it is 2 chlorine. Here also 2. Here also 2. Okay. 1 mole of this compound produces 3 mole ions in an aqueous solution. So it produces 3 mole ions. So of course this is also wrong. This is also wrong. Only this is correct because only this will give you 3 ions. 2 Cl minus and 1 CO NH3 5 NO2 plus 2. Because this will give you only 2 ions. One is CO NH3 4 NO2 Cl and other is NH3 Cl. Only 2 ions. Similarly, this will also give you 2 ions only, CuNH3 5 Cl and ClNO2. So these two will give you 2 ions only, and the compound is saying that 1 mole of this compound produces 3 mole ions. So only C is the right option. This is eliminated earlier only because it is saying 2 nitro groups and it has only one. And it's saying 1 nitro group and it has 2 nitro groups. So this is already eliminated. So this is already eliminated because of 2 nitro groups. And in these things we have only 2 ions. But the question is saying me 3 mole ions, so C is my right option. On reacting the solution with excess of AgNO3, 2 moles of AgCl is formed, which we can see from here. 2 Cl will come here and I will get precipitate of AgCl. Of course, 2 moles. The ionic formula for this complex would be C because C is satisfying all the criteria. So I can see that I can say that C is the right option to this question. Again, a simple one. We can see the explanation also. As it forms 2 moles of silver chloride, it has 2 moles of ionizable Cl, which is here. So this will go like this. CuNH35 and 2 plus 2 Cl minus. This 2 Cl minus will react with 2 AgNO3 molecules. It is basically 2 Ag plus to give 2 AgCl precipitate. This is the white PPT plus 2 NO3 will be set free minus. Okay, so option number C is the right option to this question. So moving ahead with question number 14. The formula for the complex dichlorobis urea copper 2 is what? So firstly bis. Bis means 2. Okay. So it is saying copper 2, which means oxygen state of copper is plus 2 in this coordination compound. Okay. Okay. So let's see the formula for the complex dichlorobis urea copper 2 is what? So first thing it is dichloro. So let me eliminate any option which has, okay, all options are dichloro only. So dichloro, bis means 2, urea, copper twice. So urea means in is 2, so copper is in plus 2 state. Okay, so option number C is the right option. Let's see how. Not this one, sorry, option number D is the right option. Option number D is right option. So it is copper dichloro, which is, you can see here dichloro copper 2. Why here plus 2? Because X minus 2 would be 0. This is a neutral compound, so X is in plus 2 state. So copper is in plus 2 state here. This bis is for this compound because it is twice. Urea copper 2. This is called urea. It is like this. C NH2 NH2. This compound is known as urea. So if you don't know the formation, the chemical compound how urea looks like, so they would be difficult to solving this question. But urea is like this. This is basically a ketonic compound which we study in aldehydes and ketones chapter. So it is something like this. Basically, this UNH2 group is called the amide group. So this type of compounds are known as urea. You will say these things when you will study carbon compounds in organic chemistry. So this is called urea. So you have to just search for urea in all the four options. So basically, urea is in option number D. So this is not urea because here you can't have Cu in plus two state. Bis means bis is a. Let me clear first thing this. Bis means two, and this bis is why you must be asking that why we are using bis instead of di. So di is used for compounds like chlorine, but when there are complex compounds like this, and when there is a subscript in a complex compound, when there is a subscript in a complex compound like here, then we use bis, tris, tetra, these type of words instead of di. So if you know the formation of urea, then you can easily solve this question. Again, an easy one. Just try to get an hold of if you are if you are having a hold of the entire chemistry, then you can easily do this question also. Cool. So let me write it again. Urea is like this. Okay. So you have to search for this compound. Bis means two. So here it is bis, and here is in copper is in plus two state because X minus two equals zero because this is a neutral compound. Urea is neutral. So this will give you X equals plus two, which is shown here. Okay, so this is my question number. So let's move ahead. Question number 15. Cobalt chloride forms several octahedral complexes with ammonia. I know which type of complexes like this COCl3, NH3, thrice. We know it can form octahedral complexes like this CO, Cl, Cl, NH3, NH3, Cl, NH3. Okay, it can form like this. So which of the following will not give test of chloride ions with silver nitrate? So basically how this test will go, if we have chloride ion Cl minus, then with silver nitrate, it will react to form AgCl precipitate. This comes in form of white PPT, white precipitate, plus NO3 minus. Okay, so let me erase this thing for once. Okay, so this is the kind of formation which we get when we react chloride with silver nitrate. This is silver nitrate. Silver nitrate is basically used to provide free Ag plus ions. Okay, so which of the following will not give chloride ions which will not give test of chloride ions with silver nitrate at 25 degrees Celsius? So let's see which one, because it is saying that COCl3.3NH3 will not give test for chloride ions with silver nitrate due to absence of ionizable chloride atoms. Why so? Because as I told you, this compound COCl3NH3, this is a coordination compounds. This is a coordination compound where cobalt is in plus 3 state. And it is saying that cobalt 3 chloride forms octahedral complex with ammonia. So with this forming octahedral complex, it is sure that it will not dissociate into ions. It will not dissociate into ions. And if it will not dissociate into ions, then you will not get free Cl minus. You will not get free Cl minus. Then AgCl precipitate can't be formed. So let's read. COCl3.3 NH3 will not give test for chloride ions with silver nitrate due to absence of ionizable chloride atoms because it will form this type of coordination compound. So it will give no PPT. So secondary valence is fixed for metal ions CO3 plus. It is 6. Why 6? Because Secondary valency represents number of ligands it is coordinated with. Okay, and in this case, cobalt is coordinated with six ions: NH3, 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 chlorine, chlorine. So there are six atoms, basically six ligands. So secondary valency is six here. Okay, and this is in plus three state. In plus three state, it goes like this. It will not dissociate into ions. If it will not dissociate into ions, then you will not get free Cl minus. So we can't get a ppt or VgCl. So option number D is the right option to this question. Cool. So firstly, let me make it clear. Primary valency is basically the normal valency which we study, which is the oxidation state of the central atom. Secondary valency refers to the number of ligands it is surrounded with in coordination compounds. So please don't mess with this thing. This is an important thing which is asked many times in JEE Mains. Okay, so I hope you got it. So moving ahead, question number 16. Among the following, the compound which is both paramagnetic and colored is what? So basically, we have two kinds of compound. This is KMnO4 and this is K2Cr2O7. This is potassium dichromate and this is potassium permanganate. These two type of compounds are very important compounds with respect to JEE Mains. Please study the chemistry of these two compounds at least. So a right option would be which of the following compounds is both paramagnetic and colored? So in this case, we know that CuF2 will exist in Cu2 plus state, and we know that copper is 3D9. Okay, so it would go like this. Copper basically is in argon 3D9, four S1. So it would go like this. When we will do 2 plus, then this 1s and 1 will go from here. So 1, 2, 3, 4, 5, 6, 7. There would be one more. 1, 2, 3, 4, 5. Then 5, 6, 7, 8. So we will be left with 1 here. So it is paramagnetic. Okay. So it is copper 2 plus, which is the right answer. I hope you got it because 3D94S1, when we will make Cu2 plus, then this S electron will go and one electron will go from here. So we will be left with 3D9 for 3D. One second. Hmm. So it is option number B. It is 3D10, not 3D9, sorry. That's why I was confused. So it will lose two electrons, so it will lose one from here and one from here. So we'd be left with 3D9, and 3D9 this is paramagnetic. Paramagnetic basically means that it is not paired. So if I do it again, it would be like this: Cu2 plus Fe minus. So copper basically state is argon 3d10 4s1. So when it will lose two electrons, it will be like this argon 3d9 4s0. So it would like this 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is paramagnetic because of unpaired electron. So copper F2 is an important compound. It is both paramagnetic and colored. But please study the chemistry of these two compounds. These two compounds are far more important than this one because these are directly asking JEE Mains. I hope you got why it is paramagnetic because it will lose two electrons when 2 plus state and it will become paramagnetic. So B is the right option to this question. Moving ahead, question number 17. The number of geometrical isomers for PT and ST twice Cl2 is how much? Again, a simple question. So basically, it would be like this. PT, cis and trans isomerism. So PT and S3 twice Cl2 shows GI with cis and trans isomers. So let me draw both the isomers. One is like this, and both are on the same side, and other is like this, when both are on the opposite side. So this opposite side one is called as trans isomer, and this same side one is called as the cis isomer. I think this is a very basic thing. If you're reading chemistry, you must know what is cis trans isomerism. So these are the two isomers, which is option number A. Again, a simple question. So let me draw it clearly. So it is cis and trans. Cis is like this: PT, Cl, Cl, NH3, NH3, and this trans is like this: PT, one Cl this side, one Cl opposite side, one NH3 here, and one NH3 here. Always make this straight line with the ligand which is coordinating. That's why I write it in this form. So this is called trans, like this, and this is called cis isomer. Cis, and this is trans. Okay, so this is now two isomers, cis and trans for this compound. So option number A is the right option to this question. So moving on to the next question and most probably last question for today. Question number 18. K3Al C2O4 threads is called what? So I told you many times C2O4 2 minus is called as oxalate ion. Oxalate ion. Okay. So its structure is something like this. C, one compound like this, and another like this, you can say. Okay. So there is one double bond. This is basically comes from the COOH. So this is two CO2 minus joined with a single bond. This is called as oxalate ion. So it is -2 because of these two minuses. Okay. So this is oxalate ion. So and aluminium. So basically it would be potassium aluminum oxalate. So you have to name this. So first calculate the oxygen state of aluminium. It would be X -3 into 2 equals -3. So it would be X equals Why minus 3? Because potassium is in plus 1 state, so it would be minus 3 here. So minus 3 plus 6, so x would be plus 3. So aluminium is in plus 3 state. So of course this is wrong. This is also wrong because we have not written oxygen state here. So one among this will be correct. And here we will see what uh, it is not oxalato, it is oxalate. So oxalato is not a naming, oxalate is right naming, and of course aluminium A will come before O. So option number C is the right option. So please say this is oxalate ion, and so option number C is the right option to this question because this is not oxalato, and of course. We will not write trioxalate. This tri is also not be there because it is just oxalate, not trioxalate. So option number 3 is the right option to this question, which is option number C. So that's all for today. One second, I have to recheck this one. So let me clear it. So potassium, aluminum oxalate. This is wrong. This is wrong. Among these two, not this one is not correct. Initially, I was wrong. This is correct. Why so? Because when we will see naming, we don't see A and O when they are like this. Like when one is ligand and one is the central compound. So in this case, we will not see naming. We will basically just see. We will write ligand first and the central atom afterwards. And why try? Because we have three oxalate ions. So I was confused with this one, so that's why I checked. So option number B is the correct option, which is potassium trioxalato aluminate thrice. Okay, please don't see this O and A because it is central atom and this is ligand. We don't see alphabetical order in this case. And why try? Because there are three oxalates, so we will let try. So option number B is the right option. Okay. So, okay, remaining questions, I think we can continue in our next session. So remaining questions we can continue in our next session. But one thing I want to tell you is please study chemistry of K2Cr2O7 and KMNO4 because these two compounds are really important one for especially from JEE Mains point of view. Of course, they are asking JEE Advanced also, but please study coordination chemistry of these two compounds. And other than that, there is only three, four things. One is calculating oxidation state. Second is isomerism. If you know these things, then you can easily cater with the question of JEE Mains level at least. For JEE Advanced level, of course, you need to deep dive into hybridization also and different types of isomerisms. But for JEE Mains level, this sounds good. Okay, so this is all for today, and rest questions we will be continuing in our upcoming sessions. Okay, so it's all for the. Thank you.